Okay, so for this ready, set, go, they're starting by asking you just yes or no, is something a function? And so based on our lesson, remember that to tell if something is a function, we want to make sure that it has no repeating x's. No repeating x values. And so let's go take a peek. Do you see right here, there's a 4, a 3, a 2, a 1, a 0, a 2. Notice that the 2 appears twice, right here and right here. So no, this is not a function. And that's because the definition of function is for each input, there's only one output. So if you have a repeating x, that means there's 2 outputs for that input. So no, it's not a function. The number of calories you've burned since midnight at any time during the day. I want you to picture that the x values would be the time of day. So if the time of day was midnight, and then it was 1 a.m., 2 a.m., 3 a.m., 4 a.m., we're just talking about the times during the day, and there would never be a repeat of those times. So yes, it is a function. Because as the day progresses, it's an hour later, you never have a repeat. Using number 4, we can use the same concept as number 1, where you're just looking for repeating x values. And so notice that your x values here do not repeat. So we say, yes, it is a function. Now you might be thinking, but wait a second, the y values have a repeat. What would the graph look like? -12, 25, -8, 25. Picture a graph that's basically right here. It's going to go back and up to 25, back and up to 25. It's a horizontal line. And so doing the vertical line test on that, do you see that it just touches once, touches once, touches once? So yeah, you can have repeating y's, just no repeating x's. So yes, that one is a function. Okay, let's go do the vertical line test on these other ones. Touches once, touches once. Yes, it's a function. On this next one, vertical line test. Ooh, touches twice. No, not a function. And finally, vertical line test, touches once. Oops, that one doesn't touch at all. Touches once, touches once, touches once. So this one is yes, it's a function. For every one input, there's only one output. Okay. Skipping the set, go down to the go. Now, instead of asking yes or no, it's a function, they're asking quickly for the domain and range. So I am going to go through these pretty quickly, but don't worry, I will be reviewing this in class tomorrow for anyone that doesn't remember this from Math 1. Domain is the boundary of the x values. So from left to right, where does my graph go? So this is going to go from -1 all the way over to 1. So do you see how right here is where that x value boundary is, and then all the way to right here? So my interval notation of my domain goes from -1 to 1. Now we switch our thinking for the range from bottom to top. So you're thinking, what's the lowest point of our graph y value-wise from -1 up to 3? Highest value. Why am I using closed brackets on both of these? Because of these little closed dots right here. That means we want to include the values at those closed dots on the interval. Some people like to write out the coordinate pair here of -1, -1, and 1, 3. And then they notice that the x values, -1 to 1, are the domain, and the y values, -1 to 3, are the range. So writing out those coordinate pairs can really help you identify the x values for the range and the y values for the, reverse that, the x values for the domain and the y values for the range. Okay, on this next one, you have to understand that when there's no dot, it means it goes forever. So my domain goes forever left, -infinity, and to forever right, infinity. We use open brackets for all infinities. Remember in class how somebody said all real numbers? That's another way of stating that, but they did ask us for interval notation, so we're going to leave it as the parentheses. The range goes from a boundary from here at -1 forever up to infinity. So my range goes from -1 to infinity. My domain goes from -infinity to infinity. All right, let's look at this guy. Remember, this means that these arrows go forever. So they go forever left for my domain. That means the x values are going to go all the way left. And it goes all the way up until this 2. So my domain goes from -infinity up to 2. We are going to include the 2 value. Even though it's not a dot, that spot is included in that. My range goes forever down and forever up. So -infinity to infinity. Remember, I always use open brackets on infinities. Here's my domain on this guy. Picture this window. The domain goes from here to here. So that's going to be from -4 to 2. Did you get that one? We are going to include those values. And then the range goes from here to here. From -2 to 2 inclusive. How'd you do on that? Okay, the range of this one. Notice it's just a straight line, horizontal line through a specific value. It means that the equation of this line is y equals -2. So no matter what x is, y is always -2. So what's my range? Literally from -2 to -2, or what we say to that is just y equals -2 only. And then what's my domain on that guy? It goes from -6 to 2. Notice I'm using the brackets for inclusive because those are closed dots. Closed brackets for closed dots. Okay, well, here's the opposite. Now we've got a vertical line instead of the horizontal line. Okay, so this time your x values, your domain only have one value. X is equal to 2 only along that path. So what would my y values be? So y values go from here. Now what the heck is that, right? So this is 1, 2, 3, 4, 5. So this is like 2/5. It goes from 2/5 all the way up to 6, but notice the 6 is an open dot, so we're not going to include that, so we do 6 open bracket. So from 2/5 to 6, that's the minimum of the graph to the maximum y value of the graph. Last two, notice that there's no dots on this, so we assume it goes forever. So our domain, forever left and forever right, infinity to infinity. And our range, also forever down and forever up, from -infinity to infinity. All right, last but not least, when you have dots like this, instead of using interval notation, cannot use interval, we have to use set builder notation. What do I mean? I mean x such that x equals, and then we list them out. What are the x values that are on this graph? There's an x value at -1, an x value at 0, an x value at 1, 2, and 3. And y such that y equals, this is my range, there's a y value at -5, it's a y value at -2, 1, 4, 5, 6, 7, and 7. Let me double check that last one. 1, 2, 3, 4, 5, 6, 7. Yeah, I guess that's at 7. So when you have specific dots like that, a discrete graph, you just have to list them out. You can't use interval notation because there's no points in between. Now, some people like to actually just make a table of values for a graph like this, where the first dot is at -1, -5. Second dot is at 0, -2. The third dot is at 1, 1. Fourth dot is at 2, 4. Fifth dot is at 3, 7. And it makes it easier for them to see that all these values are your domain and all these values are your range. And we're always going to list them from least to greatest. Was that more helpful to do it in terms of a table, listing out the X's and Y's so you can see that domain and range more easily? All right, last but not least, you have this little bonus question here. Are the domains of number 19 and 20 the same? 19 and 20, are they the same? And absolutely not. No, they are not. Because number 20 only includes the specific dots listed. And number 19 includes all the numbers in between. And going to infinity. Okay, so they are definitely